Hello everyone. This is Rashid Kibria from University of Florida. Today I will try to analyze the flattened gate level netlist of the GIFT-COFB cipher core using my developed FSMx-Ultra tool. The main purpose of FSMx-Ultra is to automatically extract all control FSMs present in a flattened or hierarchical gate level netlist. It recognizes all the control FSMs there, identify the region in the netlist and extracts the state transition graph using ATPG-based method. So you can find the tool inside this FSMx-Ultra folder. So if you select it, this category, it will open up a graphical user interface. The first thing you have to do is to add the technology library in .lib format. You can find that inside this library file, and I select on size 19 nanometer typical library. Next, I add the technology library in .b format. Finally, I will read the flattened gate level netlist along with the control FSMs report generated by RTL FSMx. So you can find here this one. So we have netlist inputs, and here this one is the flattened gate level netlist of the GIFT-COFB cipher core. So I select open, and next I add the COFB controller FSM report, but I do not have to add the STG report, just I need to add the FSM extraction report. So I select it, and finally I hit the extract control FSMs button. So it takes a bit time for the tool to get loaded, generate the netlist representation of the entire graph, perform structural analysis to identify the control FSM region, extract the gates, and finally to run the ATPG-based simulation. It will take just a couple of minutes. So you see the FSM extraction process was done within only 4 seconds. The ATPG tool ran. Now the FSM gate level STG extractor tool is running to extract the state transition graph in graphical format. So again, that tool is also heavy, so it takes just a bit time to get loaded. And once now the process is completed, and you can see the reports now. So I actually go to inside the tool directory now. Here, FSMx-Ultra folder, you see GIFT-COFB report, and you will find the extracted FSM report here. So FSM_1 is the netlist part of the entire flattened netlist, which basically represents the control FSM part. In this module, if we look here, we have a number of inputs, outputs, the state register, along with the pure combinational state transition logic is present here. So I basically call it as the FSM minimum extraction region, which is also specified in multiple literatures. So here we can also view the extracted pure combinational state transition logic. This one is only the state transition logic part. Now I will try to show you the state transition graph in graphical format. So this PNG file, there is only a single control FSM, one PNG file for that control FSM, and you can also correlate those with this number. This number basically represents the control FSM count, the control FSM serial number of it. So if I select open, it will show you the state transition graph in graphical format. We can also view the state transition graph in text format as well. So I will show you the verbose version of it, which not only shows you the state transitions, but also show you the state transition conditions, how many conditions you have to apply, and in which ports you have to apply those conditions. These are the thing, and this one is actually the present state wires of the netlist, and this one is the next state part, and this one is the primary inputs of the extracted control FSM netlist, where you have to apply all of these conditions. Any one of these conditions can be applied to have a transition from 110 to 110. The same thing also applies to other state transitions as well. And as you see here, we have a lot of states, state transitions. This STG was extracted using ATB-based simulation, and after that, my gate level STG extractor tool performed the reports generated by Synopsys FSMx tool to display this state transition graph in graphical and text formats. Thanks for hearing.